So web server attacks. Uh, Number one is DOS or DDoS attacks. DNS server hijacking. Attacker compromises the DNS server and changes the DNS setting so that all the requests coming towards the target web server are redirected to his or her own malicious server. Um, DNS amplification attack. Attacker takes advantages of the DNS recursive method of DNS redirection to perform DNS amplification attack. Uses compromised PCs with spoofed IP addresses to amplify DDoS attacks on victims' DNS server by exploiting the DNS recursive method. Directory traversal attack. In directory traversal attack, attackers use the dot dot slash sequence to access restricted directories outside the web server root directory. Attackers can use the trial and error method to navigate outside the root directory and access sensitive information in the system. The attacker usually performs this attack with the help of a browser. A web server is vulnerable to this attack if it accepts input data from a browser without proper validation. Man in the middle or a sniffing attack. Man in the middle attacks allow an attacker to access sensitive information by intercepting and altering communications between an end user and web servers. So here the attacker comes in between the end user and the web server. We have seen man in the middle attack in other modules also. Here here the difference is here the man in the middle attack will happen between the end user and the web server. An attacker acts as a proxy such that all communications between user and web server passes through him. Even phishing attacks can be performed on the web servers. Website defacement. Attackers use a variety of methods such as MySQL injection to access a site in order to deface it. Web server misconfiguration. The following are some web server misconfigurations: verbose debug or error messages, anonymous or default users passwords, sample configuration and script files, remote administration functions, unnecessary services enabled, misconfigured slash default SSL certificates. The misconfiguration of a web server provides the attacker a path to enter the target network of an organization. Misconfiguration can also bypass user authentication. So, web server misconfiguration examples, as you can see in the diagram: HTTPD conf file on Apache server. Um, this configuration allows anyone to view the server status page, which contains detailed information about the web server being currently used, including information about current hosts and requests being processed. So on the Apache server, this httpd.conf file, it has a location tag, set handler server status is used in the http conf file. So httpd conf file is the configuration is set in such a way that the detailed information are available uh, to anyone. Similarly, php.ini file, here the display error is set to on, log errors is set to on, error log is equal to syslog, ignore repeated errors is equal to off. This configuration generates verbose error messages. Okay, the next web server attack is HTTP response splitting attack. HTTP response splitting attack involves adding header response data into the input field. For example, by adding slash or slash n to the language parameter of the request header. Usually, the response header will contain the same value for language as in the request header. The slash or slash n from the request will make the response to split the header so that the server splits the response into two responses. The attacker can control the first response to direct the user to a malicious website, whereas the other responses are discarded by the web server. Cross-site scripting, cross-site request forgery, and structured query language injection are examples of this attack. Web cache poisoning attack. First, attacker send request to remove page from cache using pragma no cache, and then he positions the web cache by sending a request such that a random URL is infected content with infected content. The random URL with infected content will be stored in cache for the requested page. So the requested page will be replaced with a infected page. Now, any other user who requests for this page will be directed to attacker's malicious website until the cache is flushed. SSH brute force attack. SSH protocols are used to create an encrypted SSH tunnel between two hosts to transfer unencrypted data over insecure network. Attackers can brute force SSH login credentials to gain unauthorized access to SSH tunnel. SSH tunnels can be used to transmit malwares and other exploits to victims without being detected. Web servers password cracking. An attacker tries to exploit weakness to hack well chosen passwords. The most common passwords found are password, root, administrator, admin, demo, test, guest, QWERTY, pet names, etc. The attacker mainly targets the following through web server password cracking, SMTP and FTP servers, web shares, SSH tunnels, web form authentication. Attackers use different methods such as social engineering, spoofing, phishing, using a Trojan horse or a virus, wiretapping, and keystroke logging. Attackers usually begin hacking attempts with password cracking to prove to the web server that they are valid users. Passwords can be cracked manually by guessing or by performing dictionary, brute force, and hybrid attacks using automated tools such as THC Hydra and Ncrack. Server-side forgery attack. SSRF is one among the top 10 vulnerabilities of OWASP. So the attackers use these vulnerabilities to craft a request to the internal or backend servers, which normally are hidden for users. So there will be backend or internal servers which won't be visible to the other users. So the attackers will be targeting these backend servers through the front-end servers by crafting a malicious request. Once the attack is successfully performed, the attackers can perform various activities such as port scanning on the backend server, network scanning, IP address discovery, reading web server files, and bypassing host-based authentication. So all these activities will be performed on the backend server, which was not accessible to the users. Web application attacks we'll see in the next video.